Find the value of x, then tell whether the side lengths form a Pythagorean triple. First write the Pythagorean theorem. C squared equals a squared plus b squared. Substitute x for c, 4 for a, and 5 for b to get x squared equals 4 squared plus 5 squared. Because 4 squared equals 16 and 5 squared equals 25, x squared equals 16 plus 25. Next add 16 and 25 to get x squared equals 41. Then take the positive square root to get x equals the square root of 41. So the value of x is the square root of 41. Because the square root of 41 is not an integer, the side lengths do not form a Pythagorean triple. Find the value of x, then tell whether the side lengths form a Pythagorean triple. First write the Pythagorean theorem. C squared equals a squared plus b squared. Substitute 25 for c, 15 for a, and x for b to get 25 squared equals 15 squared plus x squared. Because 25 squared equals 625 and 15 squared equals 225, 625 equals 225 plus x squared. Next subtract 225 from each side to get 400 equals x squared. Then take the positive square root to get the square root of 400 equals x, or 20 equals x. So the value of x is 20. Because the side lengths 15, 20, and 25 are integers that satisfy the equation c squared equals a squared plus b squared, they form a Pythagorean triple. The flagpole shown is supported by two wires. Use the Pythagorean theorem to approximate the length of each wire. Notice that each wire forms the hypotenuse of a right triangle. The right triangles are congruent, so the wires are the same length. So using the Pythagorean theorem, x squared equals 8 5/10 squared plus 15 1/10 squared. Take the positive square root to get x equals the square root of the quantity 8 5/10 squared plus 15 1/10 squared, which simplifies to x is approximately 17 33/100. So the length of each wire is about 17 33/100 feet. Tell whether each triangle is a right triangle. Part A. Let C represent the length of the longest side of the triangle. Check to see whether the side lengths satisfy the equation c squared equals a squared plus b squared. First substitute 12 for C, 8 for A, and 4 times the square root of 5 for B. Notice that the quantity 4 times the square root of 5 squared can be rewritten as 4 squared times the square root of 5 squared. Next, square each expression. Because 64 plus 16 times 5 equals 144, 144 equals 144. Because the side lengths satisfy the equation c squared equals a squared plus b squared, the triangle is a right triangle. Part B. Let C represent the length of the longest side of the triangle. Check to see whether the side lengths satisfy the equation c squared equals a squared plus b squared. First substitute 14 for C, 9 for A, and 2 times the square root of 30 for B. Notice that the quantity 2 times the square root of 30 squared can be rewritten as 2 squared times the square root of 30 squared. Then square each expression. Then evaluate 81 plus 4 times 30 to get 201. Because 196 does not equal 201, the side lengths do not satisfy the equation c squared equals a squared plus b squared, so the triangle is not a right triangle. Verify that segments with lengths of 14 meters, 15 meters, and 11 meters form a triangle. Is the triangle acute, right, or obtuse? Step 1. Use the triangle inequality theorem to verify that the segments form a triangle. First, check to see if 14 plus 15 is greater than 11. 14 plus 15 is 29, and 29 is greater than 11. Next, check to see if 14 plus 11 is greater than 15. 14 plus 11 equals 25, and 25 is greater than 15. Then check to see if 15 plus 11 is greater than 14. 15 plus 11 equals 26, and 26 is greater than 14. So the segments with lengths of 14 meters, 15 meters, and 11 meters form a triangle. Step 2. Classify the triangle by comparing the square of the length of the longest side with the sum of the squares of the lengths of the other two sides. Compare c squared with a squared plus b squared. Substitute 15 for C, 11 for A, and 14 for B. Then square each expression. Then add 121 plus 196 to get 225 is less than 317. Because c squared is less than a squared plus b squared, the segments with lengths of 14 meters, 15 meters, and 11 meters form an acute triangle.